Hello, dear listeners. Welcome to Semaphore Uncut, a podcast for developers about building great products. In this new episode, Darko, the podcast host, welcomes seasoned software leader Maximiliano Contieri. Maximiliano discusses bridging the industry-academia gap and delves into nuances of test-driven development and clean code principles. I hope you enjoy this new episode, and let's dive in.
Today with us, we have Maximiliano Contieri. Maximiliano, thank you so much for joining us.
Hey, Darko, thank you very much for having me. It's a pleasure to be here.
Can you give us a brief overview of your career and how I ended up doing what you're doing right now?
I've been working as a teacher at the university. I've been teaching computer science for 25 years, I guess. And I've been also working at the industry in several companies for 30 years. I never quit any of them. So I have a parallel career. I've been doing a lot of stuff from programming, from quality, from a lot of stuff. But lastly, since COVID lockdown, I started to write a lot of articles, writing my experience both in the academia and in the industry. And this turned to be a book. Started heavily editing the articles, people reading them, or really asked me to compile it into a book. I rewrite all the things there. And the book is on sale now as of October 2023. And I continue doing the things I love, writing about clean code, about test-driven development and good practices, feeding from both the academia and from the industry and the industry practice.
We have recently launched a CI/CD learning tool which shortcuts into everything you need to know to level up your CI/CD process and increase your productivity. Also, to ensure that all our customers get the best CI/CD guidance, we have improved our sign-up process. From now on, everyone who's considering using Semaphore will get personalized CI/CD expert guidance from day one. Our engineers have more than 10 years of experience, so you'll surely be in good hands. Check it out on our website, semaphoreCI.com.
Maybe just to mention the name of the book before we go on.
Yeah, sorry. I'm a lousy marketing guy. The book is named Clean Code Cookbook. It's a cookbook of recipes, and it's based on Uncle Bob's Clean Code. I have my own recipes, and I've collected a lot. The name comes from the clean code definition from Uncle Bob's, and there is a show telling there are as many clean code definitions as guys programming. I don't have my own, but it's just a common topic to say how to program and how to develop software and how not to. And some recipes where you find on the industry, you find some code snippets with some practices, and with a very short recipe, you turn them into a better solution. And the reasons why you do it is not something that I say because I want, because I try to provide the reasons. So telling why this code is not clean, no? And it's very difficult because people think it's a matter of opinion, and I try to put all my experience to tell it's not just an opinion. Some things have a theoretical background, and some have practical reasons that are not so obvious for the junior programmers when you say write this code in this way, because it will have consequence when your software becomes a legacy 10 years after. I try to bring my experience and show why this maybe design decision could be not as accurate as we want.
As you said, you had these parallel careers. Can you maybe just comment on that? How do you see that career? Was it challenging? And yeah.
Yes, it's challenging because many other sciences rely on the academia first and the industry last. And since we are on the top of the technology, some things we learn in the industry are more advanced than in the academia, and some topics, all topics from the academia, are not used in the industry. So it's at a common tension. I live with it, and the common tension surfaces when I'm in one of the two worlds. When I'm in the academia and my students have never used, they don't know how the industry works, and they think that coding is like Hollywood shows in the background, in a basement and alone. We try to say, no, it's a common sport with a lot of people, with a teamwork, and it's difficult to show them. And on the other side, when you are in the industry, you say, but the industry, so it has fancy languages and mature new languages, and you say, why do you use nulls in the industry, since the academia knows that nulls are bad for 30 years and they use nulls and they use singletons and they use a lot of stuff that academia showed that they were not good a long time ago. And you need to be in between the two words. It's important for everyone to have both the weight. If you're not teaching the academia, maybe you should read things, academical things or books on something, and not just stay to the standard you use in your work and in the current stack you have on your enterprise, because that gets you into a niche and you don't see things around. But it's a tension, it's a common tension, and you need to know where you are. When I'm in front of the students, I need to be aware they don't understand how the enterprise works, because they have 22, 23 years, and most of them have, if they are working in the industry and the junior positions where people do not tell how they work, how big companies work, and just do this, and it's not good for them. And also when you are in the work, as I mentioned, you know that some things are good and come from the academia and from people that are much aware of the knowledge. And you say, well, but this guy has a Turing Award, please read it, and don't do that, because we are standing on the shoulder of giants, people that long ago discovered a lot of things, good things, and we don't really use them in the industry. We move to a next trendy thing and trendy tool, and we tend not to read Fred Brooks, Alan Kay, or maybe guys that have things to say, and we keep making the same mistakes from 40, 50 years, because we are in a very immature profession where they are not the academia and the industry. They are maybe two apart, each of them.
With your book, I assume you're primarily addressing a professional who has a number of years of experience and have seen, or was maybe the level of the reader that you assume as you were writing the book and putting all those recipes that you collected over the years in the book?
The book is mostly aimed for programmers who know how to program and have some issues I don't want to put it in a personal way, but they don't know they are making mistakes. And they want me, I'm not an evangelizer, to show them maybe this thing you are doing is wrong. Maybe you are building anemic DTOs, and maybe this has consequence. So believe me or not, if you do this in this way and you replicate your data structures in 4 ways, in the front end, you have your DTO, in the backend, you have this, and in the database, and you propagate your changes, maybe this is hurting your development process. So this is not a book to learn programming, but a book to read recipes, like Uncle Bob's. You can keep making a lot of comments on your code, but if you make them, you need to be aware they might bring you problems in the future, because comments tend to be unsynchronized, and you should write more declarative functions and classes. This is not a cookbook for solving problems, because most of the idea of the cookbook came from the editor, and it is not a common cookbook, because I have a lot of cookbooks from the same publisher, and the cookbooks are, you need to do this in order to do this, you can do this. So if you're working on a cookbook on JavaScript and you want to sum 2 numbers, hopefully you don't need a cookbook for that. This is a recipe. You take one number, you send it the plus function, and you get the sum. But this cookbook is not so special, because it is helping you solving problems you maybe don't know you have. So one of the problem might be SQL injection, but you may be not aware. So if you have this and you can have an attacker, write this instead. This is not how to avoid every injection. No, it's just read this and take it into account in order to make better software. This is for security, for reliability, for coupling. Lots of recipes are related to coupling and how all your changes make ripple effects, and everyone needs to change what you have recently programmed, and the impact is too huge. A new business rule takes a lot of months to ship. And why this is happening? Because you're making some design mistakes. So if you apply the recipe step by step, like a refactoring to your code, you can avoid this and have a better time to market, for example. And this is a book to have it as a back of the mind. You can read it like a dictionary. You have it and you read it whenever you want. You go to the index and read it.
Yeah, you need to index it and have it in the back of your mind. And when you encounter a pattern and situation, hopefully a pattern recognition will kick in and you will remember.
Yeah. You will say, I read this guy told me that I should not use singletons as a say. I have a singleton, but I don't know what are the problems. So I bring you and say, this is a singleton, this is the problem, this is how you change it and turn it into dependent injection or whatever. And the book introduces a lot of it has a glossary of a lot of good practice, not only solid practices of test-driven development, that when you read, you might say, oh, let's Google this thing this guy is telling me, and you want to learn principles like don't repeat yourself and a lot of this. So it encourages you to read other books. That's what I wanted as a end use, as a writer, to the people to read more books and on data specific solutions and languages, because the book is language agnostic. It has sources in 25 different languages.
We have recently launched a CI/CD learning tool which shortcuts into everything you need to know to level up your CI/CD process and increase your productivity. Also, to ensure that all our customers get the best CI/CD guidance, we have improved our sign-up process. From now on, everyone who's considering using Semaphore will get personalized CI/CD expert guidance from day one. Our engineers have more than 10 years of experience, so you'll surely be in good hands. Check it out on our website, semaphoreCI.com.
Generally, the practice of, TDD and just writing tests and covering your code with unit tests and, all other kinds of tests, that was significantly lacking. That it had also a major effect on the quality of code that people are writing in terms of, readability, maintainability, and all of that. So can you maybe speak a bit also from the historical perspective of you and your teams, introducing the practices of maybe, test-driven development and generally that, and what are the effects on the clean code?
We use a lot of TDD on new systems. Later, the TDD evolved and we started to use in legacy systems. And it's difficult. I following Ken Beck. He says TDD is not for everyone. TDD is not for anxious people. TDD is not, it has a lot of cultural problems because people tend not to hard code, and TDD favors you to start hard coding, not to end hard coding, but start hard coding. And people tend not to hard code, and people tend to over engineer things and design algorithms as long as it sees one pattern and they say, oh, there's a mammal, there's another mammal. And humans don't work like that. We work in baby steps. We see there's a dog, there's a cow, and then we generalize and we discover the mammals. But computer science is tend to overgeneralize and start and anticipate and make gold-plating things. TDD works on test cases, on evidence, not to foresee what will happen if. This is a problem, and TDD and Kenbeck also tells this. And also that some kinds of software are not working good with TDD, maybe machine learning, because TDD needs for you to understand which will be the outcome, so you can write a test and you can cover it with a hard-coded solution. Always hard-code with TDD, and after you hard-code a lot, you need to refactor. But since you have a lot of your tests written, you can rewrite all your things, not before, because you have your knowledge base. TDD is based on incremental learning. It's a learning methodology. It's not a testing methodology. I might say it's not even a development methodology. It's a thing. It's a methodology to discover how the world works. So when you're writing your test cases, you are making use case extraction, and you are learning. And since you're learning, you're making mistakes. And this goes well beyond with David Farley's book about modern software engineering. David Farley says we need to be experts at learning. And we are not very humble as computer programmers. We talk to a user, a real user, or to a marketing user, and we think we know all we know. Suddenly, not even good users know what they want. We need to learn together. And this is something that nobody does this. Nobody does. And when you go with this uncertainty and with TDD and no, I don't have evidence, I will not code this. Computer science programmers tend to overthink before we have evidence. And this comes from the academia and the scientific method that says don't work until you have evidence. We have a tension between science and engineering, And engineering, I'm in computer science. Yeah, I'm also in engineering, and I have my own tension. And engineers tend to solve problems, and computer science and scientifics tend to work under evidence. David Farley's book says we need to be both of them. And TDD is a great methodology for discovering, for learning, and for building. So it's very special. But whenever I give TDD talks, I give a lot. I record one yesterday. I'm going to show next week at Chile about TDD. People read it and said, I don't believe you. I cannot do that. And whenever they start, they're frustrated. I say, I will write one test, but I'm not hard coding. I'm not Putinese. I cannot hard code. I cannot write this minimal solution because I know the algorithm. And sad news, you don't know the algorithm. You only know the algorithm whenever you have written a good suite of regression testing, of good tests, and your algorithm works. Because in one of my talks, I developed one of the katas with TDD, and then I go to ChatGPT. I use a lot. I heavily use a Copilot and ChatGPT, and ask him for an algorithm, and the algorithms do not work with all the test cases we have discovered. This is the thesis. We have the algorithm, but we don't know how it should perform. And we cannot change the algorithm since we don't have the test case as a regression. So when you have TDD, you ship a regression test and a good knowledge extraction of the current instant point of the knowledge of your business. And this is stated on the tests. And as soon as you don't discover new things, this is your truth. And since programming is building good models, this is what good is about, good scientific models of how we think the world should behave. All we need to do is understand what we can see from the world and put it in a behavioral way into TDD, and after that in the software that honors the TDD behavior. It's a different approach than normal because we tend to write code without understanding how the code should work. And TDD forces you to write code in a minimal way on how it actually behaves. But it's not a silver bullet, and this is something that Ken Beck also tells. This is not suitable for everyone, and you need to test it, and it has a lot of re-education and a lot of ramp-up.
One of that ramp-up period is extremely hard. I would say it almost also, it's very proportional to the age of a person. So someone who had spent writing code the last 15 years without writing TDD and now throwing that person into a TDD train, there is going to be, some...
a reeducation, a rehab for all coders like ourselves.
Yeah, rehab.
I'm pretty old.
Rehab is a nice word. Can you speak a bit about employing TDD in legacy systems?
You cannot write all your code using TDD until you remove the coupling and the problem. You cannot. You will not be able to add a new feature using TDD, but you can use TDD in isolated parts of the system and start to decompose the legacy system, and you can read Michael Feder's on the Sims model on how to decompose a legacy system. And you can use it TDD. You can cover parts of the system, and if you are good enough and you work enough, your TDD will become a better system. What you cannot do is, I have a big legacy, I have a database, I have a front end, I have a lot of legacy code heavily on globals. Well, it will be very difficult for you. But in the talk I develop an optimizer of the database performance. And since the optimizer takes an SQL and gives you another SQL, you can inject it in a TDD way. And what I also show in the talk is how in TDD, all of the team members work, not just the developer, because the QA also writes his tests using TDD, and the functional analyst writes behavioral tests using TDD. And they all inject the solution together. And once I will spoil it, once you ship it to production and for sync conditions are seen, you inject the new case, because if you have a problem in your code, you need to start writing a case. You ship your test case with the QA and the technical support things addressing how this new behavior should behave. And this is injected in an isolated part. But in order to isolate the part, you need to break some coupling, and you can do also, after a couple of years, maybe many different parts are rebuilt using TDD. And this is complementary to the Michael Feder book that I think it was before. I think it was previous to TDD. But you can do it with Feder's thesis on the seamless work and how to put small parts with TDD. So you can use it in a greenfield. It's easy. In a legacy system, it pays off. It's your choice. Try it. And try it hard. No, don't try it a couple of days because it is for anxious people. So it's frustrating. It's frustrating. Of course, it's frustrating. You are educating. You are in rehab.
As you were mentioning how you structured the book, maybe you can give us like overview how you ended up deciding to structure it in such a way. And
well, I've written about 400 articles since the COVID pandemic. I've written about 3 or 4 per week, gathering code. The book is structured in several different chapters. The first part of the book is about the thesis that you need to model to create a simulator of the real world. This is the thesis of the book. And after that, all the rules are related to how they impact the simulation and the behavioral. It talks about primitive obsession. I'm enumerating some of the chapters. The mutability, that's a very important concept in real world things to be unmutable and in software things to be mutable. Declarative code, a lot about naming. I'm rephrasing Uncle Bob's many naming rules. About comments, how to write, code standards, complexity, bloaters that tend to gather a lot of things together. Yagni about the things you write in your code you will never need it. The fail fast problem, a lot of problem with ifs and nested conditions on ifs. The null problem, the null is the biggest problem we have nowadays. A lot of premature optimization, coupling, globals, testing, technical debt, exceptions, metaprogramming, which is also a big problem, and security. And that's most of what the book is about.
What are the main pointers where people can find more about you? Maybe where
you can follow me at Twitter, I would say x.com. My name is MCSEE1, I think. I gave a conference last week. I'm having another one, as I mentioned, next week. I recall postal like your own. Thank you very much again.
Maximiliano, thank you so much for sharing all this knowledge and wisdom that you gathered over so many years. Again, for people who want to learn more, feel free to grab a copy of the book. Thank you so much again.
Thank you very much again.
What a great conversation. We hope you enjoyed it and learned something new. Make sure to subscribe to Semaphore Uncut on your podcast player of choice so that you don't miss our new episodes. And stay tuned.